you walk into your physics example and you know exactly what to do concerning some topics. So I will be sharing with you some likely topics that will come out in your questions. I'm talking about the WAEC 2026 exams. These questions, these topics have been recurring over the years and they will likely occur again this year. One of such topics is waves. I'll talk about waves today, and I will also talk about electricity. Now, under the waves, I'll be talking about the waves equation. In the second part of your physics, I'm talking about the theory part of your physics. There are some questions that will come at the section A, and there are some questions that will come at the second section, the section B. Now, this question is one of the questions that can come in the section B. The section B carry more marks than the section A. Section A just have short questions, but I have a question on the board right here that has about 3 or 4 questions in one. Okay, so this kind of questions, they will earn you more marks in the exams if you're able to answer questions like this. So I'm talking about wave equation. So I'm going to be answering this question on wave equation. And if you have not seen my video on wave equation, you can actually pause this video and go check it up where I broke it down. And I also added the link to that video. I added it in the description to this video so that you can see. Now, let's look at this question on the board. A plane progressive wave is represented by the equation y equals 0.5 sine 1000 pi t minus 100 pi x divided by 17. That is the question. Where y is in millimeters, t in seconds, and x in meters. Calculate frequency, the wavelength, the speed of wave, and the amplitude. So the first thing you want to do here is you want to write out the progressive wave equation. The progressive wave equation. So I'm going to write that equation out for you, and I'm going to give you a shortcut, a short formula that you can use to remember this progressive wave equation, and it will be simplified for you as well. And I will also derive some other equations from these that you can use to answer questions that you are asked in the exam. The first thing you want to do here is to write out the progressive wave formula or the equation, which is y equals to a sine wt. Some call it, or the symbol is actually omega t, all right, omega t plus or minus kx. Well, I would like to call it wt for a reason as we continue. So this is the main equation. I can label this equation 1. Now, this w is giving us where your w is 2 pi f, all right, and your k, this k is actually 2 pi over lambda. Where your k is 2 pi over lambda, your w is 2 pi f. Now, what does each of these, what do they stand for? I'm going to state that out clearly as we continue. But before we do that, I'm going to derive other equations from here using these two. Because if all you have is just, if this is all you know, you won't be able to answer questions. So you need to know how to derive other equations. But before we derive the equation, I told you I was going to give you a shortcut, a short formula, a mnemonics that you can use to remember this equation. So this is y equals a sine wt plus ax. Now, the acronym is as in, this is as in Watkins. As in Watkins. Now, there is a footballer whose team just won the Europa League recently. The name of the footballer is Oli Watkins. Okay, so Watkins, that's his name. Now, but we are going to borrow that name Watkins. We use it in physics so that you can easily remember. So instead of only Watkins, it's going to be as in Watkins. So what is Watkins? Watkins is the WT plus or minus KX, kicks. So as in Watkins. So once you just write as in Watkins, put it, the Watkins in bracket, then you have your equation. Now, so let us try to derive other equations using this original equation. So my y is going to be a sine. So this w is the same thing as 2 pi f, so I can write it as 2 pi in place of w. 2 pi f is there, then t, my t is there, plus or minus. Instead of k, I represent it with 2 pi over lambda, that is k, multiplied by x, so 2 pi x over lambda. This gives me equation 2. Now let me derive another equation. So I can have y equals to a sine. Now, if you recall, our f equals to, if you recall, v equals f lambda. V equals f lambda. V is velocity, f is frequency, lambda is the wavelength. So v equals f lambda. So if v equals f lambda, I can replace my f with, so f will be what? V over lambda. So if f is v over lambda, I can replace this f. If I'm replacing, I'm going to have 2 pi v over lambda t. So this portion stands for my f. I've replaced it with v over lambda. So I have 2 pi vt over lambda plus or minus 2 pi x over lambda. This is equation 3. Let's try to derive more equations. So from here, I can have y equals to a sine, all right, 2 pi vt over lambda plus or minus 2 pi x over lambda. Now, something is common to this side and this side. 2 pi over lambda is on this side. 2 pi over lambda is on this y side as well. So I can say y equals a sine. I can factorize the common factors, bring it out. 2 pi over lambda into bracket. What would be left here? Vt plus or minus 2 pi over lambda coming out here will be left with x. So this is equation 4. Let's try to derive another equation 5. Okay, you know your f equals 1 over t. F is frequency equals 1 over period, that's 1 over t. So if f is 1 over t, I can derive another equation from equation 2. So in place of this f, I can replace it with 1 over capital T. So I'm going to have y equals a sine, you know the original is 2 pi ft plus or minus 2 pi x over lambda. So if f is 1 over t, I can as well say y equals a sine 2 pi 1 over capital T times t, all right, dot t plus or minus 2 pi x over lambda. That's going to be y equals a sine 2 pi 1 over t will be 2 pi t over capital T plus or minus 2 pi x over lambda. And of course here I can factorize this. So this gives me equation 5. And then I can go ahead to factorize and give me equation 6. A sine 2 pi into brackets t over capital T, all right, minus x over lambda, equation 6. So you can continue to derive your equation from all of these, from this major as in Watkins. I hope that is clear. Now we're going to try to attempt this question using any of the equations on the board. Now, so let's answer this question. The question now says we should calculate the frequency. So to calculate frequency, the first thing you want to do is to look for which of this equation has frequency. There is no frequency here, but there is a frequency here. So I can use equation 2. So I'm going to write out my equation 2. So to answer the question, equation 2 is what? Y equals a sine 2 pi ft plus or minus 2 pi x over lambda. That is my equation 2. And I'm looking for f. So all you need to do to answer the question is to place this side by side with the original question. So what's the original question? Original question is y equals 0.5 sine 1000 pi t minus 100 pi x over 17. So if you compare these two equations, the first thing here, this A stands for the amplitude. You know, I told you I was going to tell you the meaning of each of these. So your A stands for your amplitude, this is your angular velocity, or yes, the angular velocity omega. This is your time in seconds t, and then you have, I've told you the amplitude, this is the frequency, all right? This is the wavelength, the wavelength, lambda is the wavelength. Then your V is velocity, all right? Your V is velocity. All right, so now this D question says we should find the amplitude. So without even wasting time, the amplitude did this question. So if you place it side by side, you see that your A is 0.5. So your amplitude is 0.5. So the answer to D is 0.5. That is the amplitude, right? That is the amplitude, 0.5. You can place it in meters because we're going to be dealing with meter per second for velocity, and then so meters, that's the amplitude. Now the next thing, let's go to frequency. So question A says we should look for frequency. So how do we look for frequency? Can you see this part has the frequency? So you equate this part to this. How do you know which part? Now, this is plus or minus. Plus or minus means this part can come first before this part. If you look at the original formula here, WT can come to this side, KX can come here. There are different ways they can ask the question. All right? So that's why you have plus or minus. So whichever one comes first, it still works well. So whether it's KX before the WT or the WT before KX, plus or minus. So here we have exactly the correct thing here. So just equate this to this. When we do that, we're going to have our frequency now will be what? 2 pi ft. So equate this to 1000 pi t. Now on the two sides, we have, what do we have in common? Pi t. There's a pi t here. All right, so pi t cancels out each other. So what do you have left? 2f equals to 1000. Then you can divide both sides by 2. So our frequency is 1000 divided by 2 is 500 hertz. So the answer to the frequency question, the frequency in this equation is 500 hertz. I hope that is clear. Now we've answered frequency. So now we're going to attempt the wavelength and the speed. The speed is also the velocity. So we're going to attempt the wavelength and the speed. Now come with me. Let's talk about the wavelength. So how do we answer the question for the wavelength? Remember, the wavelength is lambda. So we need to compare the equation given to any of these our equations that has wavelength. So you have equation y equals to a sine 2 pi ft plus or minus 2 pi x over lambda. So let's compare this to the original equation that was given to us. That is y equals 0.5 sine 1000 pi t minus 100 pi x over 17. Now, if you compare this and this, you see they look alike. So you're going to equate this to this. If we equate this to this, we're going to have 2 pi x over lambda equals to 100 pi x over 17. All right. So pi x cancels pi x. So you have 2 over lambda equals to 100 over 17. So for us to find the wavelength, which is the lambda, we cross multiply. So you're going to have 2 by 17 is 34. 34 equals to lambda times 100 times 100. So you divide both sides by 100. Our lambda is going to be 34 over 100, which is going to be 0.34 meters. So that is the wavelength. So the wavelength option B, wavelength lambda is equals to 0.34 meters. The first one, frequency, is 500 hertz. Now let's go to the next one, which is speed. C. What is speed? Speed is the same thing as velocity. So how do we get our velocity? Where V is F lambda, I stated it here. V is F lambda. So velocity is frequency times wavelength. So if that is the case, our velocity is actually going to be frequency, which we have solved, 500 multiplied by wavelength is 0.34 meters. So if you calculate that, 500 multiplied by 0.34 meters, 170 meter per second. So that is the velocity. The velocity is 170 meter per second. The wavelength is 0.34 meters. And the frequency is 500 hertz. And of course, the amplitude is 0.5 meters. Now, we have answered this question. We have answered this question. If there is any part of this you don't understand, you can rewind and then try to go through. Now, we are going to the next likely topic that will come out in your exam, and that is electricity. So I'll be teaching you how you can calculate the, in Nigeria, we have the NEPA bill, right? That is what you pay to the suppliers of electricity, the company that supplies electricity. So how do you calculate your NEPA bill? That is a likely question that will come out in your WAEC exams. So I am going to take another question right now where we'll be talking about that. Come with me. You have an electric circuit and you have a bulb connected to, in the diagram above, a bulb is lit by drawing 2.0 amperes from 440 volts AC source. Calculate the cost of keeping the bulb on for 2 days at $0.40 per kilowatt hour. Take note of that. So let's quickly draw out the parameters given. The diagram above shows a bulb is lit by drawing 2.0 amperes. That is the current. Current is 2.0 amperes from a 440 volt AC source. That is the, you can call that the potential difference or the EMF. All right, so the potential difference is 440 volts, or the voltage, as the case may be. Now calculate the cost of keeping the bulb on for 2 days. So the time is going to be 2 days. And what does 2 days stand for? In each day we have 24 hours. So you're going to multiply 2 by 24 hours. That's going to be 48 hours. All right? So 48 hours. 2 days at 0.4. So the rate is what? 0.40 per kilowatt hour. Listen, look at this. Not per kilowatt per hour. Not kilowatt per hour. Many students make mistakes here. They will just say kilowatt per hour. That okay, if it is 8 naira for 1 kilowatt, then how many per hour? No, this is kilowatt hour. The meaning of kilowatt hour means kilowatts multiplied by hours, by the number of hours. Is that okay? So the first thing you want to do is to look for the power rating, or the power that will have been consumed from this. So if your voltage, let me represent your potential difference with voltage V. So what's the formula that connects current to voltage to power? It is P equals IV. P equals IV, where P is power, I is current, V is voltage. So if P equals IV, we are going to have P equals to I is 2 multiplied by V, 440. That's going to be 880 watts. So the power consumed by the bulb is 880 watts. But remember, this is in kilowatts. All right? The rate is what? Per kilowatt. So kilowatt means we have to convert this to kilowatt by dividing by 1000. That's going to be 0.88 kilowatts. So we've gotten the power rating, or what have been consumed. Now the next thing is that they now said calculate the cost of keeping the bulb on for 2 days per at 0.40 per kilowatt hour. So what you just need to do, look at it, kilowatt hour. So you are multiplying this by the 2 days. So the cost is going to be 0.88, the power in kilowatts, times hours, which is how many hours? 48 hours. Then multiply by the cost per kilowatt hour. That is 0.40. So when you multiply 0.88 by 48 hours by 0.40, your answer is going to be $16.90. And we have that in the option. So option A is the answer to this question. So it could be in naira, okay, it could be in dollars, and then whatever the case may be, the answer is 16.90. So they can give you another question. They can tell you 3 bulbs, 2 fans, electric fans, 1 iron, and all of that. At each rating, they give you the rating of each one. All right. So when they give you the rating of each one, you should be able to actually galvanize them together and come up with the answer. So before I close, let me quickly give you some basic formula that you're going to be using for electricity that can help you. The first one is, let's look at V equals IR, which is the Ohm's law. So I'm giving you these equations. V equals IR, that's the Ohm's law, where your V is the voltage, I is your current, R is the resistance. Then you have P equals IV. P equals IV, power equals to current times voltage. Now, if P equals IV, we're still coming back, then you have H. Its energy equals to IVT. H equals IVT. All right? Equation 1, equation 2, equation 3. H equals IVT. So if H is IVT, that's its energy, right? Or which is the same thing as work done. So work done is equals to energy equals to H IVT. So I can replace this IV with P. So my work done will be equals to PT. So if they ask you to calculate energy consumed by a body or the work done, your PT, W equals PT. I hope that is clear. So let's look at other ones. What else can we do? Since V equals IR, I can make R the subject. R will be V over I. So if R is V over I, okay, so I can now introduce, anywhere I have R here, I put V over I. Anywhere I have V here, I can put IR. So let's, from this equation 3, since we have V here and V is IR, so our H is going to be equals to I dot, instead of V, it's IR dot T. That's going to be I squared RT. So this is equation 5. So we've derived equation 5 squared RT. Now from R, we can replace with V over I. So H will be I squared times, instead of R, replace with V over I, multiply by T. So this I, we cancel one of this I squared, and you have ordinary I. So your next will be H equals to IVT. So that was how we got this H equals IVT. I hope that is clear. So let's try to derive more. Now from here, you recall that V equals I. If I make I the subject of formula, I will be what? V over R. So if I is V over R, I can replace any of this I with my V over R. So if I replace from here, P equals IV, replacing I with V over R, that is P equals IV, but because I is V over R, P will be what? V over R dot V. And that will be what? P equals to V squared over R. That is another equation. So let's label that equation 6. V squared over R. Let's have another one. What if I replace in here, I replace my I with V over R. If I replace my I with V over R, since H equals to I squared RT, and I is what? V over R. So if I replace this I with V over R, I have H equals to V over R squared RT. So that's going to be H equals to V squared over R squared times RT. So R cancels one of these. So I have what's plus V squared T all over R. V squared T over R. So that's equation 7. All right, I hope that is clear. Now, from all of these, you can actually answer any question that relates with electricity using any of these equations that I've treated on the board. And the last one I'm talking about, which I'll be doing in the next video, I'll be talking about resistors in series and parallel, how to calculate total voltage, total current passing through resistors in series and parallel. I hope you have gotten value from this class. Stay tuned for the next video and do well to subscribe to this channel if you have not subscribed to this channel. On this channel, we give you videos on physics, on mathematics, on chemistry, biology, sciences generally, making sciences fun for you. Thanks for being a part of this. If you have not subscribed, subscribe, share this video with your friends, like and drop your comment. And bye for now.